guess I'm being spontaneous. Somebody help me! I'm being spontaneous! Forget Fiji. Can't very well drive to Fiji, can we? What about Atlantic City?
And where are we driving this lesson? We want to come up with rules that we can follow to decide what the right curve should be. And the number one best way is if you can base it off of the theoretical truth. If an expert came to you and said, oh, I know what this relationship should be. For example, how much wood, and we're using that to predict the age of a tree. Well, an expert would tell you that there's a square root function defining that. Great, now we know the right curve to use. I just finished promising that in this class we're going to focus only on polynomials. So we're not going to talk about how to do the square root function. You could probably figure it out. And we've got an extra problem that we don't know the theoretical models in this class, and there isn't some expert that you could go and try to talk to. So this particular method isn't one we're going to use a lot. But speaking of using polynomials, you could fit a quadratic, probably wouldn't fit right here, but maybe a cubic would, and it might not match exactly perfectly, but it gives us good results. And within the amount of error that we have, it's going to work out fine. Which is why the second rule here is that it should have good residuals. And it might be that multiple models would fit this curvature enough to give us good predictions and have good residuals. And you can imagine someone saying, yeah, x cubed fits this curvature really well. X to the 25th power would also fit this curvature well. Yeah, but you really need to go all the way up to x to the 25th power. That seems overkill. And if you look at the p-values, they'll tell you, yeah, all these extra powers aren't really helpful. X cubed would probably fit this pretty well, and beyond that, you don't need it. So you should have good p-values. And you could imagine someone saying, okay, x cubed fits well, but e to the x over the sine of x plus 1 over x also fits well, and maybe that would give you a low p-value, but you're going to have to be able to explain this to a client. Which one's a little easier, x cubed or e to the x over some trig function? That's one reason why in this class we're going to focus mostly on polynomials. And with the right polynomial, you can fit any data with a curve. There's even a calculus theory called Taylor's sequence that can prove that. So we're going to focus on using polynomials, but if you want to use something else, you can. Which brings me to the fifth point. There's more than one good model, and you can use any good model that gets good predictions out of the data. If it has good residuals, good p-values, and you feel comfortable explaining it, then great. All of those models that have good predictions qualify as appropriate models for this data. Just because I said there's more than one good model does not mean that every model is necessarily good. There do exist bad models. You can't just go with any model and say this is the one I have. It has to be something with good residuals, good p-values. If you're not comfortable with how the residuals look, then that's an indication that you don't have one of these good models. Your model is bad. Or if you're unhappy with the p-values. But this is one reason why you could give the same data set to two statisticians, and they might return with two different models, like the red line or the black line. Both fit the data well. Both give you good predictions. Both qualify as the answer. That means judging whether you have the right curve is based off errors, based off residuals and p-values, but not based off having to need the exact correct model as someone else. The next video is going to talk about places where different statisticians might argue or disagree about what the right model might be.